Hi, I am Ahmet Eren Kartal. I am a freshman student at Bilkent University Electrical Electronics Engineering Department. In this video, I am going to introduce my Physics 101 project, which is simple harmonic motion at spring. My aim in this experiment to demonstrate that while the period is related to the mass, it's irrelevant to the amplitude. The materials I used in my experiments are as seen here: a spring, three different masses, a puck, and measurement and calculation tools. At first, I needed to find the spring constant to use it while calculating the theoretical period. To do this, I took three pucks and found all the pucks' masses. After uncovering the mass, I hang each of the masses separately to the spring. After that, I found the amplitude. By using Hooke's law, gravitational acceleration and mass, I calculated the constant of the spring. I wrote the values I found in table 1. By using these values, I calculated the k value that I will use in my calculations. After that, I started conducting my experiment. My first aim was to understand the relation between mass and period. To achieve this, first, I chose a mass and put it on the puck. I calculated the total mass to use my calculation. Then, I attached the puck to a spring. I put the system into the airtable. By pressing the pedal, I enabled the airtable to reduce friction, and I started the motion. I observed 10 complete oscillations and recorded time passed. I calculated the theoretical period by using the mass and k that I found. I wrote what I found in Table 2. I repeated this process for the other two masses. After that, I derived the graph of t versus square root of mass. From the slope of the lines, I calculated the error and error percentage. I found a 45% error in these measurements. This error can stem from the uncertainty of measurement tools and human factors since I start and stop the timer. Although the airtable reduces friction by a significant amount, there is still friction between the surface and the puck. This friction causes the puck to gradually slow down and stop. My second aim was to clarify that the period does not depend on amplitude. At first, I chose a mass to use while conducting my experiments. I put this mass on the puck. I put the puck into the airtable. By pressing the pedal, I enabled the airtable to reduce friction. I pulled the puck in six different amounts, and I started the motion. I observed 10 complete horizontal oscillations and recorded the time. I calculated the theoretical period by using the formula. Then I found the error and error percentage. I wrote what I found in table 3. As I mentioned earlier, because of the uncertainty, human factor, and friction, some errors occurred. In addition to these errors, the k value found by me contributes to the error, since it was calculated with uncertain values of length, gravitational acceleration, and mass. Experiment demonstrated exactly what I expected. While conducting my experiment, some errors related to the friction and uncertainty occurred. To reduce these errors, more precise measurement tools can be used or more care can be taken while conducting the experiment.